Ultimately, GitHub Action is no more, no less than remote code execution as a service. What else is that? It's a machine waiting for commands to be executed blindly, right? So that's highly risky, right? On the part of GitHub, what they do to protect themselves, they have virtual machines that are just ephemeral, that are created just for that every run.
Okay.
And they trash it, they create a brand new machine, but they don't do much to protect the people kind of that specify this GitHub Action workflow to protect against the untrusted input that go into that. In the case of open source, it's a public repo. People can send bug reports. They can create pull requests, and all that ultimately is processed in GitHub Actions. And it's potentially untrusted code, untrusted user input. So yeah, just traditional web application security problems, and people don't think about that so much.
Welcome to the season 3 of The Elephant in AppSec, the podcast to explore, challenge, and boldly face the AppSec elephants in the room. I'm Alexandra, your host and AppSec enthusiast and growth manager at Escape. Today, I'm joined by François Proulx, Senior Product Security Engineer at BoostSecurity, where he leads the supply chain research team. With over 10 years of experience in building AppSec programs for both large corporations like Intel and innovative startups, François has been at the forefront of the DevSecOps movement. He's also one of the maintainers of the Poutine security scanner, which detects misconfigurations and vulnerabilities in build pipelines. Be sure to check it out on GitHub and give it a star. François is a frequent speaker and one of the founders of the NorthSec conference, where he also serves as a challenge designer for the CTF. In this episode, we dive into the critical topic of supply chain insider threats and open source projects. We discuss the importance of the trust but verify mantra and how the transition from a single maintainer to a team can increase security risks. If you are wondering about the future of automated security checks on platforms like GitHub and the specific vulnerabilities in build pipelines, this episode is for you. If you enjoy this podcast, don't forget to subscribe and follow it on your favorite podcasting app or YouTube. It's the best way to avoid missing future episodes. And with that, get ready to hear François' opinions. Dive right in. So, hi François, I'm very excited to have you on the Elephant in AppSec podcast with me. It's, because Christmas is approaching right now, so it's very festive season, and I think people maybe pay less attention to everything that's going around in security. I think they're already thinking about decorating Christmas trees like we discussed, and not especially patching vulnerabilities and securing code. But I think if you're still passionate, like you still take this time to contribute to open source projects that you are building or maintaining or passionate about. So it's actually you can refocus maybe your time for that. And I think recently you wrote also an article, about how we should focus on supply chain threats and open source projects, right? And the integrity of open source is something that's a lot reliant on trust with the community, and trust that people who contribute, to those projects are actually thinking also about security sometimes, but it's also might be, a dilemma for the people who, for the maintainers, for the core, builders. Should they, you give access to everyone? How do you actually make sure that all the contributions, to the repo are also done with the security in mind? How to make sure that project, is not exposed, to significant risks. So in your experience, especially since you wrote that article, how do you think, the core maintainers should approach that? How should they approach, granting access while kind of minimizing those risks?
Yeah, thanks for having me. So, I think first of all, most open source projects, they start by receiving contributions using pull requests. Like the traditional model on GitHub is that you fork the repo and you kind of you suggest a contribution using pull requests. And that's, I guess, much safer to begin with versus adding a new kind of direct contributor. That's much more rare, especially for much smaller projects. They typically have just one maintainer, and then at one point they grow and they might add more direct contributors. And I think that's that's the risk that I kind of discussed in one of my articles, is that when go from a single maintainer to an actual team, like a small team of contributors, you need to really trust those people. And if we look at what happened in the spring with the XZ project, that was basically the whole deal, is that it was a project very well respected that existed for more than a decade, and it was literally like a one-man team like project. The person unfortunately was burnt out, like simply
quite happens a lot on
tired of contributing for 10 years and just like things happening in his personal life. Unfortunately, like threat actors noticed that in some way, that it was like the combination of a highly trusted, like very critical project with single maintainers still after more than 10 years. And they quickly realized that the guy like could be social engineered into accepting not just malicious contributions, but to become a trusted maintainer alongside him. And even then, threat actors in that case, treated it as a long, journey over more than a year to before they would get something malicious in. That's kind of like an extreme case, but it did happen. So that's a learning moment, I think, for the community, is that even in that scenario where someone comes in with good intentions and want to contribute, I think as the maintainer, you need, and well, especially if you've never met the person like face to face, I would say the most respected projects, they really build a community, and they have maybe small events where they gather people in person and just really builds extra trust. So yeah, but if we kind of go back to like starting from just accepting contributions through forks, sending pull requests, even that is already risky. You need to, code review what the contribution is about. And the more complex the contributions are, the more unlikely it is that the code review will be exhaustive about everything. So I think that's one thing already that maintainers might want to pay attention. If someone makes almost their first contribution is a big contribution, it tries to kind of hide something inside of a bigger contribution, that could be a red flag. But even like smaller contributions can be quite tricky to audit, especially when you think about supply chain of adding references to other dependencies. So like you could have a very small contribution that, for instance, is like, hey, how about we start to use this other library instead of that one? And it happens that library is actually like kind of a Trojan horse.
Some vulnerability as well.
Or it's just like it will have a vulnerability or will have like a contribution. It's like adding new contributions, adding new dependencies is risky for a number of reasons. Those could have known vulnerabilities, could have vulnerabilities down the line, or could be themselves co-opted. So it can get quite complex quite fast, like when you consider all aspects of supply chain. And yeah, so.
But like quite often they say, developers don't care about security. So let's say if you don't build a security related open source project, but it's entirely for development purposes, and you don't have that security knowledge.
Yeah.
How do you check, let's say have 10 pull requests per day, it's a very popular project. How do you make sure then that something that's there is not vulnerable?
That's a very tough problem. I think it's something that people unfortunately are only realize when it's too late, that so much of critical infrastructure relies on open source at scale, and the kind of distributed nature. I mean, that's kind of the beauty of it, is like literally anyone can contribute something valuable to open source, and then people, start to rely on it, and it just keeps going on and on. Like people, are passionate. They have their little side project, and it can, be co-opted. There can be vulnerabilities that are not intentional, just like, regular vulnerabilities that we know of, like in typical OS top 10 and the likes. And then it's open source, like people can audit the code, find the vulnerabilities, keep it for themselves as 0 days. So yeah, it's a tricky thing for projects that are not thinking about security that much.
I think in this case, maybe the mantra that you mentioned, before trust but verify is probably the best approach, but kind of hard to, if you want to release something quickly, and quite often you want to release something quickly, it's hard to implement at scale.
Yes.
Especially like in case of burnout. If you're burnout, you already don't think, in general about verifying everything. But how would you recommend to apply that?
I think it's a community effort. I think there are experts, like security experts, that dedicate like me and others their expertise to help those maintainers that are very good at making good open source libraries. They're too busy, making it work, making it, more efficient, faster, better, and all that. Yeah. So I think there are projects like the Linux Foundation's open source security foundation is effectively all about that. So it's first of all, like it's a challenge of making an inventory of everything, all the open source projects out there that exist, kind of ranking them by criticality. They have what they call the criticality score, which takes a number of variables, the number of stars on the project, the number of forks, the age of the project. Has it existed for 10 years or like just 1 month? How many downstream dependents? So basically how many projects depend on that one, right? The other way around. Like so the more of those variables come into play, the higher the criticality score is, and they will dedicate more resources to ensure that the scenarios of like burnout and the kind of bus factor, like someone unfortunately gets sick, like physically sick, ill, or unfortunately dies, like that will be more and more a problem over time. Security overall is still pretty young in the human life, right? There are like
all that is always like 20 years ago.
Pioneers of computer software from the 70s, in many cases, are still alive, but they're approaching, like 70s, 80-year-old. So literally over the course of the next decade or so, we will see people that have been there since the very, very beginning pass away. And we need to think about the legacy of those projects, like make sure that people understand like how to continue maintaining it. In many cases, there are projects that are more or less done. Like there's not much else to do. Like it's stable. Like let's take XZ again. It's a compression library. I mean, once it works, it's fast. Everybody's happy. What else? You don't need to add like new cool AI, rainbows to it.
You can always imagine something.
Of course, no, there can be completely new algorithms, but like if you say XZ is about this specific compression algorithm, you compress, decompress, it's fast. You can make it faster. Like you can fix bugs where it crashes in some scenarios. But when it's been like 10, 15 years, it's, you need a very good reason to go and mess with that. So, but that doesn't mean that as people, move on, that new people, they need to really understand how those critical pieces work, so that if someone needs to go and fix something, they do it with like full understanding of the consequences. It's
And why do you think, for example, or do you think in the future, for example, GitHub will implement automated security check in all on every merge request or something like that? Because right now it's kind of we have to manually verify the pieces of code. Sometimes you can implement additional tools in your workflow, but you have to be the one that implementing them. Do you think like GitHub eventually, since still there are some players like GitLab that are dominating the field, that is it something that they must actually implement within their system?
I think it's a bit tricky because people who typically contribute to open source like to keep independence. And if we just take the fact that, when Microsoft acquired GitHub, a lot of people like left GitHub for that reason, right? They didn't want to continue using a product like funded by Microsoft, which was seen years ago as the evil. but now more and more Microsoft is one of the biggest contributor to open source. Like they literally probably the biggest, if not like in the top 3. So it has changed quite a bit since like the early 2000s. But to get back to your question, could they do more? Of course. But to what extent will it work for every... It's very hard to have a one-size-fits-all solution. There are so many projects that have a long history and different like technologies, different programming language, different all sorts of conditions. So it's, I mean, I know a lot about like statistical analysis tools and things like that, and it basically, nothing is bulletproof in that. Like it always adds like false positives, and it pisses off like people to have to review the results from that. So I don't think to kind of force it. Definitely they could offer more. Like they're already doing that. Like the CodeQL, you can use it for free in public repos, but it supports, a certain number of languages. It's kind of clunky, it's slow, but it's out there. Like, yeah, GitHub offers it, but how many projects use it? Not so many, because it really only works well or for the types of projects that the commercial, the paid users, the enterprise users of GitHub want the product, the CodeQL product, to work on. But it's not necessarily the same reality for open source, especially like older projects.
Okay, so people just generally do not really want to use an extra check because it either slows them down or because it's too noisy.
Yeah.
But then, for example, I don't know, something that just signals careful, this library, is in the list of potentially vulnerable libraries. That could be like a simple potential.
Yeah, no, for sure. I mean, there is like Dependabot that's been there for a long time. I think it's much out of all the things that GitHub offers for free for public repos. I think Dependabot is the most widely used one because it kind of does that quite well. It's fairly lightweight. I think the majority of open source projects use Dependabot, but it's still pretty simple. There are many things that Dependabot could do better.
Like what?
Well, I mean, it doesn't give so much context about like, it just said, okay, there's a new version, you should update. But for instance, when you update multiple dependencies all at once, you just know, oh, there's a new version of it, and why should I update it? Like it could add new problems. It could break something. It could add new vulnerability. It's not always the case that newer is better. Okay. Newer is more secure. Not always. And in the scenario where there's a backdoor that is added to a new version, well, of course, it's going to be worse. So I guess if it's not broken, don't fix it,
Yeah.
So from that perspective, but at the same time, we all know that if you don't update, like aging software tends to have known vulnerabilities. So, Dependabot, if it kind of, they kind of categorize the version update versus security updates, at least. So they will say, okay, in that version, there is a CVE that gets fixed. That's one thing. But to kind of like because you kind of rely on what the maintainers of the project say that the update is about, right? It's really based on, here are the changes, but that's a human deciding to write that versus what are the actual changes in the code, which it can be quite complex. And not to mention like we go back to the whole thing about like verifying the code. It's one thing to verify the code statically, but dynamically how it actually behaves, like the performance considerations, for instance, it might not be obvious when you just look at it. Could Dependabot like really do much better in that respect? Hard to say, but definitely that's one thing that is quite popular in open source projects.
Basically, the solution, at least try to verify as much as possible manually, I guess. And I think you've done some great work on identifying, 0 days in open source packages yourself, right?
Yeah.
Maybe, I think, you shared it on the podcast with Chris Romy, if I'm not mistaken, as well. Like, could you share more about what you've done?
Yeah.
And especially, I think, how people responded to it.
Yeah, so I think the niche, the kind of little specialty that we have in my team is that we don't really look for vulnerabilities in the code itself. There's tons of people doing that already, bug bounty hunters, like just doing finding vulnerability. That's great. It's not that we cannot do that, like we're competent to do it, but we think that there's already enough eyeballs looking at that. Where we focus is looking at vulnerabilities in the supply chain itself of the open source project. So, and especially in the build pipeline. So basically the CI/CD. For instance, in GitHub, what's most popular is GitHub Actions, because again, it comes for free if you use GitHub as an open source project. GitHub Actions is built in. It's very easy to use, and it has a lot of great features. But there are types of vulnerabilities like that are specific to GitHub Actions workflows, and it's been documented for some years. I think it goes back to the year 2020 or 2021, so it's not like super brand new. But I would say that it's, I don't know if it's because of the pandemic, like people swamped with other things, but it kind of
they
went,
had time to spend
a little bit
in front of the screens.
under the radar. And only more recently, maybe a year and a half ago, more people like us started to pay attention to that problem at scale, and really look at almost the entirety of open source projects and start to create tools like the one we wrote to find this kind of problem on as many open source projects. The interesting thing about that is that, again, it's not in the project's code directly. It's in what is used to build the final artifact, and in most cases people kind of don't care much about that. They just don't put the same level of attention, time and quality, because it's just seen as a tools to achieve the final goal, right? And that means that there's tons of problems. People kind of do that a bit sloppy, unfortunately, and also in many cases those build pipelines, they get quite complex quite fast when they start to pull multiple dependencies, compile for multiple architectures, and run tests and do all sorts of other automation, not just purely like compiling, testing, like validating, and then finally publishing the artifact. In some cases, projects use it to automate, just as a quality of life kind of automation tool for open source projects. So they use it to kind of clean up certain unused files and like validate bug reports automatically and things like that. So, and for us, the way I see it is that things like GitHub Actions and other build pipelines that are kind of tightly integrated with the source code management, they're really just a software as a service application, a web application that processes data coming from the internet. In that case, it's basically data that either you input in the GitHub user, like in a, you submit a bug report, you put a title, a body, and put some comments, and things like that. Like if you think in traditional web application security, that's just some potentially malicious payload, like untrusted payload that goes into a web application, in that case, GitHub Actions. And then it starts all sorts of complex processing. Ultimately, GitHub Action is no more, no less than remote code execution as a service. What else is that? It's a machine waiting for commands to be executed blindly, right? Because that's all you ask for it. Like you give it the script, run it for me. So that's highly risky, right? So like on the part of GitHub, what they do to protect themselves, they have virtual machines that are just ephemeral, that are created just for that every run. And they trash it, they create a brand new machine. So it's just, typical cloud provider protection, like anything that AWS needs to do to protect themselves, but they don't do much to protect the people that specify this GitHub Action workflow to protect against the untrusted input that go into that. So in the case of open source, it's a public repo. People can send bug reports. They can create pull requests, And all that ultimately is processed in GitHub Actions, and it's potentially untrusted code, untrusted user input. So yeah, like just traditional web application security problems, and people don't think about that so much.
Yeah, I think more and more developers, software engineers, they now publish articles about tools that they use to how they developed, certain feature. And for commercial software, they mention open source projects that they use. So for someone who really wants to know what kind of open source projects the commercial organizations use, they can go on there now engineering blogs that quite often exist for extra hiring purposes, kind of try to scrap, the whole blog, find the name of the open source project, and then potentially even run a scanner for detecting vulnerabilities in this open source project, and then attack the organization. And there are a lot of, also open source scanners that exist, and the ones that can be used publicly. I think you have also built your own scanner, Poutine. How do make sure that, for example, in this sequence of events, someone finding, open source repo that someone uses and testing this repo, how do you make sure that they're not misused actually by someone else? For example, I know that at the early days, of Escape, people were signed up. A lot of like bug bounty hunters or pen testers were just signing up for free to test the application, and hackers as well, and we had to ban them. Like we got flag alerts all the time from users and scans, and had to ban them. It's very hard to do, at scale for open source scanners. So how do you make sure that they're not misused?
Well, we simply can't. It's not, the big difference, I think, from your perspective for Escape, it's a service. It's a software as a service. It's a backend. Like it costs you guys money to run the infrastructure, and you have paid customers that you want to guarantee that there's no like denial of service of like other legitimate users, right? And overall, yeah, as an enterprise, as a company, you don't want, like for reputational purposes, you don't want your tools to be used, like misused. But when it comes to pure open source, especially a tool like Poutine that we built, it's just a command line tool. Anyone can download it, anyone can run it on their computer, and it doesn't like connect to any backend. Like you just run it locally. All the logic is inside of that. So there's really no way for me to know that someone is using it to find vulnerabilities and exploit them for malicious purposes. Of course, I know that many people at the big and small companies are using it to protect their own stuff. We use it to detect vulnerabilities in open source projects at large, but especially for the project that we depend on, like our own like infrastructure boost, like we kind of proactively hunt for vulnerabilities in the build pipeline of our own dependencies, and then we do it for everything else. Then we do responsible disclosure, but we cannot prevent bad guys to do the same. It will happen. That's just the part of the game. So it's important for people like me to speak on podcasts and go to conferences, write articles, spread the word about that, so that it's not just the bad guys that know about those techniques and those tools that like we build that are trying to make it easier to find, like instead of just doing it manually, right? All my know-how, all my expertise to find it like that, I used to do it kind of manually. I wrote tools to automate that. Now I put it in the hands of people that are not experts, and I try to give as good documentation, both to explain, to educate people on those new types of vulnerabilities and how to remediate, to fix it. So that's really, just like typical. It's like any other vulnerability, software vulnerability, OWASP top 10, everybody knows it. And, both good guys and bad guys. So knowledge is power. So how can I prevent? I would say that from the perspective of the defenders, they need not only to be proactive about, understanding, if we talk about the open source, like inventory, all the dependencies you have, and then look for known vulnerabilities like CVEs and whatnot, like just SCA. That's, much more mature by now, and we're generating an SBOM, all that stuff. But then we expand to, okay, like we're keeping up with known vulnerabilities. Maybe you have enough expertise, which is quite rare. like only larger organizations will dedicate time of people to look for 0 days in those things, like Google, Microsoft, Red Hat, and all that. They have enough people to look proactively,
To
look
build,
like basically like
to do manual stuff.
reports those vulnerabilities and end up having CVEs. Either the maintainer finds it themselves, in most cases they just fix it, then they don't necessarily take the time to report as a CVE, which happens quite often, so like there are things that have been patched. So a previous version had a vulnerability, it was patched, but does it mean that the maintainer took the time to report it as a CVE? Not necessarily.
Most likely, I think in most cases, they're not probably.
So it's really the tip of the iceberg. So that's why there's a reason to kind of update dependencies, even if it doesn't say it's a security update, because it could have a security update, but it's not quite clear. But yeah, then if you get more mature, like you want to consider those like more supply chain kind of complex scenarios, which come from all sorts of angles. Like the developer's laptop itself is very, like it's the starting point of where the code is. And that laptop, typically people use their laptop for many other things. They browse the internet in the evening, and they play games. They install all sorts of tools to help them do their job. But those things like Visual Studio Code extensions, for instance, they could be malicious, and then they're just sitting there while you're writing code. They can kind of modify the code before it gets pushed. And like if you work in a company and you have teammates, hopefully they kind of code review that and could get cut at that point. But you want to really have good processes in place to enforce that, so that it's not just on the Honor system that the GitHub, repo configuration, like using branch protections and things like that, or repository rule sets, is going to effectively enforce that even if you try to push to the main branch, it will prevent you unless you're an administrator that will go and disable that. And that should leave traces like in the audit trails, and someone else should regularly review the audit trails to look for something suspicious, like how the hell did you disable branch protection at 3 a.m. on a Saturday and then push to main branch? That's weird, right? So
did you have cases like that personally?
Yes,
someone
we had a customer of ours that, in fact, I don't remember the exact story, but in the end, we developed something in our product that does exactly that. So we automatically process the audit log of GitHub organization for our customers, and we detect those kind of anomalies. A repo that had branch protection, it got disabled for 30 seconds and then re-enabled. And during that period, someone pushed a commit. We found that for a customer, sort of by chance, don't remember the exact circumstances, but we investigated it, and only to realize that it was not malicious. It's like some project manager that needed to ship to production like a fix and kind of bypass the process. That was done without the security team knowing. And once we put the feature in our product in place, we realized that project manager was doing it quite frequently. In fact, like maybe once every 2 weeks or so. It's kind of bypassing the process, and it became on their radar. And now, well, hopefully they're kind of being a bit more proactive about finding why that is. Maybe like there needs to be at least a process for that, like documented. So thinking about the supply chain from the moment like the code gets written to when it has a chance to be reviewed by peers, like, and really think about that seriously. Like, and then the build pipeline, which is the kind of specialty that we have, finding vulnerabilities in that build pipeline, because it can be potentially compromised in so many ways. Like, at build time, you pull dependencies, like those open source packages that you depend on, they typically are downloaded during the CI phase, and then you run tests. So you pull more dependencies that only exist to run the tests. Those dependencies don't go on to be part of the final artifact. So those are extra dependencies that you don't put so much care into picking, maybe, as long as they get the job done to run the tests. But ultimately they run like in a sensitive environment that that is used to push the final artifact. That environment may or may not have various secrets that authorize it to push to some production environment and whatnot. So there's an opportunity to kind of exfiltrate those secrets and, misuse them to put a backdoor in an artifact. So that's something to think about. And the actual registry where the final artifacts are stored, let's say, AWS ECR that stores Docker images. And then finally, like in some production environment, those Docker images or other dependencies are used. And then it's traditional web application security, DAST, like what the Escape is doing and whatnot. And then it's more about, not just considering the attack from outside in, like web application vulnerabilities, like entering through like the firewall and getting all the way through the load balancer to the application. But if the vulnerability or the backdoor came in literally with the software through the supply chain, now you need to think about malicious or unexpected behavior of the software running. The attacker is already in, right? So you need to
you have to
monitor that. Suddenly, your application that's supposed to accept, the response for a survey and then store the results in a database, just display them, suddenly starts to connect to other system, pivot laterally.
Send data somewhere else.
Exactly. So it's about kind of profiling the expected behavior at runtime and detecting anomalies. That would be ultimately what you want to do, but you can do that at multiple stages in the supply chain.
If you would have to, sum up for someone, let's say, still open source security, it got a huge topic this year because exit, backdoor, but still it's relatively new in terms of awareness, I would say. If for someone who is just getting started with it, who maybe didn't have anything much implemented yet in place, what are the, top 3 priorities would you recommend for them to implement in their organization?
I think branch protection, like if you're you have an enterprise, you write software as a team, if it's just as soon as you have more than one person contributing to a project, and even if you're alone, I would still recommend to use branch protection just to force you to structure your work in small code changes, right? Not just like a big chunk of updates, push the main branch versus be diligent about pushing changes that are pretty small, that can be easily understood, that are well documented. And have someone else on the team code review and potentially like a comment, like you make improvements, then it gets merged. And make that enforced through branch protection, repository rule sets. There are so many best practices. If you kind of look very carefully at the documentation, depending on your level of needs, you can kind of enforce that the tests run, that the tests pass with your criteria of maybe having 100% success on the test and like 100% coverage, code coverage, things like that. That would be like, increasing the maturity. Also, I would start with that. That's like really ensuring that.
For number 1 priority.
Yes. After that, I would say keep track of your dependencies, like produce an SBOM, have someone look at it and challenge that why you may have so many dependencies. Maybe you can simplify, like just like limit to the strict minimum. Often, like if you go back some years ago, there was the famous case of an NPM library called shift pad left or something, which literally was like a library that had one line of code. I'm not even joking. It was just like
hello print.
The packaging around the NPM package was bigger than the actual code. And all it did, it was just like a function that did like a simple mathematical operation, like validating if the certain number is greater than, like it's a positive or a negative number, something super simple. And why is there a library that does just that? So it just shows like the complexity of dependencies, and you want to challenge that, like keep it simple and like not in that case, like maybe reinvent the wheel. If it's validating that it's a positive integer, just do it. Like just write code. Like don't be so lazy and use a dependency to do that. So, and then keep track of CVEs, like patch, and not especially the more critical ones. So you want to maybe filter through the noise, because again, like you have so many dependencies and so many CVEs, which one of those like you should patch. To that, what I would recommend as a third thing would be, if you're using Docker containers, Docker images, start with a base image that is as minimal as possible. So instead of using like Ubuntu latest or something, which most people do, like as a base layer for a Docker image, use things like chain guards base images like Wolfie. So they're very, very small like base image that have the minimum number of dependencies. I go back to start with the minimum, the strict minimum you need to get your application working. And if it works, if it does what you need, good. And then maybe trim even more.
Then you can celebrate.
Yes, because then the less dependencies you have, the less potential vulnerabilities to patch.
Makes sense.
Then, I mean, in our experience, when we shifted from Ubuntu latest kind of image to chain guard and distro-less type of image, we went from, say, 1,000 kind of CVEs that we couldn't even patch because they were part of the base image, and the maintainers of Ubuntu, they just say, like we keep those CVEs because they're not so risky. And so they made some decisions on your part that like they're not going to patch it, but you still have tons of dependencies. Then like you pile on other actually risky ones, and then you end up with 3,000. You need to kind of ignore 2,000 out of the 3,000. No, it's better to have zero, like literally like zero. But and then when there's one, you care about it, right?
But I think from what I've seen, it's almost impossible to have zero. I think criticals usually fix, not always usually fix, but even highs sometimes not really. In some cases, it depends how lean organization is and what's mean time to remediation there. It's a bit tough topic, especially the larger org. Funnily enough, the harder it is sometimes to fix.
Yeah, but
something.
To that, I would say that the next thing is like you need to automate. Like just it should be automatic. Like there shouldn't be as many human like churn to do this kind of basic task of just updating a point release, not a major release. Of course, if it's a major release, it can break everything. But if it's like a minor version, you should just have it all automated tests, pass, and you should hopefully just merge it. Like if you have a good test suite, you're confident that your software still does what it should automate, right? That's what we do. Like we have processes that literally suggest like once a week, like a big kind of pool, test everything, just okay, like let's ship it in a staging environment, let it run for like smoke tests for some time. Okay, ship to prod.
And there is one question I always ask at the end of the podcast. That's really, what book would you recommend? But actually, in your case, since you run also yourself, NorthSec conference, I was thinking like, what talk would you recommend, to someone to really listen, to understand the topic of open source security? This podcast, but so it's probably more conversational. But if there will be, one talk that you would really recommend them to watch, what would it be?
There are many. I mean, shameless plug.
You have to pick one.
Shameless, my talks are on YouTube, but there are others that I really like. I think Adnan Khan did a very good Black Hat and DEF CON talk in summer 2024. You can look it up on YouTube. Adnan Khan's talks about GitHub Actions security. Very similar, like a fellow security researcher doing similar work. So it's kind of eye-opening. I think there's another, a bit more like philosophical kind of consideration about like supply chain issues, like the grand scheme. Ross Cox from Google, who is heading the Go development. There's another great talk from about a year ago at kind of more academic conference that I would highly recommend looking up for the Ross Cox keynote talk from about a year ago. Yeah, those are great ones.
Okay, well, Thank you so much for sharing, and thank you so much for coming on the podcast, François. It was a pleasure talking with you, and I really hope that it lets us spread a little bit more civilization and awareness around that topic. And I'm sure within the next years there'll definitely be more and more to come. At least you see definitely more and more tools for that. So
we
sure.
have pretty interesting ideas for next year in terms of research, and we're kind of lining that up, and it's already very promising.
Okay, excited to see the results. Thank you so much.
Thank you.